The Global Assessment of the International Science Policy Platform on Biodiversity and Ecosystem Services, or IPBES, highlights that both constructed infrastructure and natural solutions can support efforts to mitigate and adapt to climate change. Indigenous and local knowledge, or ILK systems and practices, is acknowledged by the Intergovernmental Panel on Climate Change and IPBES as a means of assisting in the adaptation to climate change and the sustainable management of biodiversity and ecosystem services. Nevertheless, there is still a lack of consistent application of ILK systems in efforts to conserve biodiversity or adapt to climate change. To address this, a 3-year cooperative research project, entitled The Integration of Traditional and Modern Bioproduction Systems for a Sustainable and Resilient Future Under Climate and Ecosystems Changes, or the ITMoB, was initiated. The project aims to explore pathways and scenarios for a sustainable and resilient future under climate and ecosystem changes. The project evaluates the various ecosystem services provided by bioproduction systems under multiple future scenarios, focusing on integrating home gardens, agroforestry, plantations, aquaculture, and urban agriculture in Japan, the Philippines, and Indonesia. The ITMoB project is part of the eAsia Joint Research Program, involving global partners such as the Institute for Global Environmental Strategies, the University of Tokyo, Osaka University in Japan, and Pajajaran University in Indonesia. In the Philippines, the ITMoB Implementing Agency is the Interdisciplinary Studies Center for Integrated Natural Resources and Environment Management, University of the Philippines Los Baños, and led by Dr. Juan Pulhin. It covers the 2 significant watersheds in the country. The project commenced on October 16, 2021, and is in its 3rd year of implementation. ITMoB Philippines is supported and funded by the DOSTP card. Throughout its implementation, significant accomplishments have been made, and despite several challenges, the project team, composed of a pool of experts ranging from graduate students, early career researchers, and academicians, remains determined to achieve its goals. The project is currently on track to provide positive results in identifying climate-resilient pathways that offer effective adaptation options under the changing climate, demography, and land cover. Moreover, as the project promotes and emphasizes co-learning, co-development, and co-management, partnerships with academic institutions located within or adjacent to the project sites will be vital in providing sustainability and building long-term learning sites for students to conduct their research. In the end, this action research for development model could advance science-based and multi-stakeholder anticipatory planning and decision-making at the local level to optimize the socio-economic gains of varying combinations of bioproduction systems while minimizing ecological and environmental losses in the process.